Hey everyone, Mike here from Arnold Tutoring.com with a rational function inequality that we have to solve and show graphically. How do I know it's a rational function? Well, there are x's on the bottom of fractions, and when we're going to combine this all, there's going to be x's on the top and the bottom. So a polynomial over a polynomial means it's a rational function. One of the tendencies may be to multiply everything, so both sides, by the common denominator to get rid of the fractions. That's what we would do if this was an equal sign, but we have to realize that this is not an equal sign, it's a less than or equals to sign. So in order for us to be accurate with our graph and our solution and not miss any solutions, we have to keep the bottom of our rational intact, so we can't really cancel anything right now. So the first step is always to get everything to one side, because we like to, so I'm going to minus the 4 over 3x onto this side, because we like to compare inequalities to 0. The reason we like that is because on one side of 0 it's positive, one side of 0 it's negative, and it's much easier to see. Now we want to get a common denominator, which is going to be 3x. So 6 over x, I have to multiply top and bottom by 3, so I'll end up with 18 over 3x. We can think of this as 3 over 1, so I have to multiply top and bottom by 3x. So I get 9x over 3x, and there's already a 3x under the 4, so I'm good to go with that. That's less than or equal to 0. Again, that's just grabbing a common denominator. Now we can put everything together. So I get 18 plus 9x minus 4. It's all over 3x. And that is still less than or equal to 0. And if we complete that as 14 plus 9x over 3x is less than or equal to 0. So that is, again, taking our rational function. Once again, if this was an equal sign, we would just multiply this 3x to the other side and get 0, and we'd just have our 14 plus 9x. But if we do that, because it's an inequality, we're going to miss some of the rational functions, so we don't want to do that. So, what can we figure out from this? Well, there's a few things. I'm just going to start listing some of the characteristics of rational functions. So the x-intercept is the x value that makes the top 0, or the numerator 0. So that is we can just set the numerator to 0 and solve for x. So I'm going to set that to 0, and we get x equals negative 14 over 9, which is just, negative 1.5, something like that. How about a y-intercept? That's when x is 0. Well, we can see that making x 0 will make the bottom 0, so there is no y-intercept, does not exist. How about vertical asymptotes? Vertical asymptote is the x value that makes the bottom 0, so that is going to be x equals 0. That will make the denominator 0. And the horizontal asymptote is something we've looked at in other videos. We look at the degree of the numerator and the denominator. So the degree, or the highest x power, is 1 on top, 1 on the bottom. When those are the same, the horizontal asymptote is going to be the coefficients of those terms. So it's going to be y equals 9 over 3, because those are the coefficients in front of the biggest x terms. So it's y equals 3. You could also put these values on a number line. So the rule is we want to put any value that makes the top or bottom 0. So I'm going to put negative 14 over 9 on a number line, and I'll put 0 on a number line. Now we just test values on either side. So if I put a really big negative number in here for x, I'm going to get a negative on top, negative on the bottom, and that's going to be a positive. So it's positive over here. Negative for any x value in between these two, because the top will be positive, the bottom will be negative, and then a positive over a positive, everything will be positive. So you don't have to do that, but it helps us paint the picture a little bit better. Let's put all of this information in. So I'm going to start with the vertical asymptote. That's x equals 0, so that's just this green asymptote at the y-axis. Our horizontal asymptote was y equals 3, so I'll put this through at 3. Our x-intercept is negative 14 over 9, so again, it's about negative 1.5. I'll just estimate it right there. And we can either do some tests or see what's going to happen. We know that as x gets really close to 0 on the negative side, we're going to negative infinity. So it's going to ride along that asymptote and this asymptote. And on the right side of 0, when x approaches 0 in this function, but from the positive side, we're going to have a positive over a positive very small, which is positive infinity. So that's going to be coming from way up here. It's going to ride along the asymptote there. So I would focus on these 4 characteristics of the rational function in order to graph it. The last thing we need to do is highlight our solutions on this graph. So we were looking for wherever this rational function was less than or equal to 0. So you can see this is our key x interval from negative 14 over 9. So from this point to this point. So it's all down here. If we were to write this in a solution, in interval notation, it's going to be from negative 14 over 9. That's going to have a round bracket around it, 14 over 9, all the way to 0. Sorry, that's kind of messy. Let's try that again. Negative 14 over 9, that's with a square bracket, and 0 will have a round bracket because 0 is the spot of the vertical asymptote, so we actually never get to 0, versus negative 14 over 9, that's when the function is defined at 0, and since we're looking for it less than or equal to 0, we do include that point. So this is a way to highlight our solution on the graph. We've also shown it here in interval notation, and we've done all the work to show all the characteristics as well. Hopefully that gives you a good idea of how to deal with these rational inequalities. Everything to one side, compare it to 0, and then find those 4 characteristics and put them on your graph. Thanks so much for watching. You can always send us more questions, info@arnoldtutoring.com. Thanks.